today I'm going to talk about stem and leaf plots. So what is stem and leaf plots? It is a special table which each data values is split into two parts, which are stem and the leaf. So what is the characteristic of the stem and the leaf plots? Stem is representing the first digit or digits, and the leaf is representing the last digits. Stem value are listed down, and the leaf values go on the right or on the left of the table. The stem is used to group the value, and each leaf shows the individual score within each group. Okay, now let's learn how to read and create the stem values. First, you need to choose the stem and then arrange the order, and after that add the leaves. To make it clear, let's take a look to the example. There are a group of numbers here, which is 15, 16, 21, and so on. And now we're going to decide the stem by choose the first digit of the numbers. So for example, number 15 and 16. So what is the first digit? The first digit is 1, right? So the stem must be 1. And then number 21, 23, and 26. What is the first digit? The first digit is 2, right? So the stem is 2. Also like that. Also number 30, 32, and 40. The first digit is 3 and 4. Okay, we already have the stem. 1, 2, 3, and 4. After that, we need to choose the leaf. The leaf, we just write down 5 and 6 besides 1. And then for 21, 23, and double 26, we just write 1, double 3, and double 6 beside 2. And then for number 30 in the row 3, we just put 0 and 2. And in the row 4, we just write 1. So the first row representing 15 and 16. The second row is representing 21, 23, and 26, and so on. So that's how to read and create the stem and plots. Okay, that's all for me. Thank you. Let's go to the next material.
Alright, after we know what a stem and leaf plot is, how to read it, and what it means, we're moving into the next or another form of stem and leaf plot. Let's say we are tracking touchdowns or TDs scored by football teams. A stem and leaf plot helps us see the data at a glance. For example, if teams scored 37, 33, 32, and so on, our plot would look like this. Okay, here 3 to 37 represents 32, 33, and 37 touchdowns. And then 2, 0, 1, 2, 3, 8, 9 represents 20, 21, 22, 23, 28, and 29, and so on. The problem is what happens when there are too many leaves. Like, imagine if 20 teams scored in the 20s. So one row would be too long and hard to read like this. The solution: we split the stems. So instead of making a single row for 20s, we create two. One for 20 to 24 and another for 25 to 29. Now it's clearer. We can easily see how many teams scored in each range, like 20 to 24, 25 to 29, 30 to 34, and 35 to 39. Now let us discuss about back-to-back stem and leaf plots. This method allows us to compare two sets of data visually. For the structure, as you can see, the middle column, it is called stems, represent the 10 digits. Left side, it is leaves for one group of data. Right side, it is leaves for another group. So, if you are wondering how to read back-to-back plot, this is so easy. So, to read the leaves on the left, you need to see the stem on the middle column and then you go to the left. Same way, to read the leaves on the right, you need to see the stem on the middle column and then you go to the right. Easy. For example, here there are two sets of data. First from 1998 touchdown score on the left and 2000 touchdown score on the right. How to read it? So, to read 1998, first we go to the middle column, which is the step, and the number is 4. Then we go to the left, the leaves, there are two leaves, and the number are 1 and 1. And then we combine it, 4 and 1. 41. So it means that on that year in 1998 there are only two scores. What about the other? The row is empty. What does it mean? It means that there is no touchdown score on that year in 2000. Benefits of back-to-back plots. Why are these plots useful? First, of course, because they allow us to easily compare the two groups. Secondly, with this method, we can quickly see how the data is spread out, the range of values, like the highest and the lowest, and lastly, the patterns or the similarities and even differences between the two groups.
Alright, I'm Lima Sugraha. I will continue the material from Saras. From Table 2 presents data from the weapons and aggression case study. The values represent mean time differences across multiple trials when subject name aggressive words, like punch, under two conditions. In the first condition, these words were preceded by neutral word like buck, while in the second, they were preceded by weapon words like gun or knife. The experiment investigated whether weapon words would accelerate pronunciation of aggressive words compared to neutral words. Positive differences indicate stronger priming effect. Data range from 43.2 to minus 27.4. A value of 43.2 means one participant pronounced aggressive words significantly faster when preceded by weapon words. Conversely, minus 27.4 indicates another participant actually pronounced aggressive words more slowly after weapon words. Data range from 43.2 to minus 27.4. A value of 43.2 means one participant pronounced aggressive words significantly faster when preceded by weapon words. Conversely, minus 27.4 indicates another participant actually pronounced aggressive words more slowly after weapon words.
Alright, I'm Rasmita Putri. I will explain about box plot. A box plot, also known as a box and whisker plot. Box plot is a visual representation of a dataset distribution, displaying the 5-number summary. The plot indicates how the data is spread out and skewed. The 5-number summary includes the minimum, first quartile or Q1, median, third quartile Q3, and maximum values. Now let's see some of the features of this box plot. This is a box plot. Let's see the first one. Box plots make use of 5 main calculation. We make use of the smallest number or least number in the data, the lower quartile, which is commonly called the first quartile, the median, the upper quartile, which is also the third quartile, and the maximum or biggest number. And the gap between the lower quartile and the upper quartile is what we call the interquartile range. Using the formula, you can just do it by subtracting the lower quartile and the upper quartile. We talk about that further in our calculation. This is a typical example of a box plot. You can see the maximum number is 13. The upper quartile here is 10. The median is 8. The lower quartile is 5. The smallest number is 0. And if you want to work it all the way down to the interquartile range is 10 minus 5. The upper quartile minus the lower quartile, and I'll give you 5. Okay, I think that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Iksan Juliana Siombing and my student number is 018. Today, I will explain how to use Excel and SPSS to make box plots. Let's begin. Here, I have prepared a set of data scores that we will calculate using Excel. Now, when we scroll down, I have a column here that we can use. Insert the function equal quartile, highlighted the array you want to calculate, like this, and then press 1 to determine the 25th percent. As you can see, that is the 25th quartile. We do the same function on the second row, but using the ending with comma 2, which means 50%, which is also known as the median. And there is the median. And then there is the 75% quartile. You insert the same function, add comma 3, and then close the bracket. There you can see the 75th percent quartile. Next, we move on to SPSS. We use the same data score as you can see here, and then you press Analyze, press Descriptive Statistics, and then Explore. After you explore, put the data into the dependent list. Okay, I'll do it again. Here, as you can see. Then enter the plots and see that the plot has been check marked. Continue and then press OK. Now you can scroll down and see the box plot below. I think that's all from me. Thank you very much.